Hey folks, it's Professor John Baugh again, and we have another exciting episode of C++ programming. This is session 9, which is a deeper look at classes part 2. The chapter is chapter 9 as well. It's a continuation from last week. We can look at the syllabus just to see where we are. Okay. We can look at the syllabus and we can see that I'm actually, even though today's the 2nd of July, I'm actually recording for the 8th, week of the 8th. So all of you should be watching, at least this week, you should be watching the first part of Chapter 9. This week we're going to continue a look into classes, and also I'm going to be assigning Project 3. So Project 2 is due at 11:59 p.m. Friday, meaning the Friday of the week of the 8th, so that means the 12th. Okay. So hopefully all of you have started on it, taken a look at it at least, and for those of you who are having difficulty or who didn't get a very good grade, perhaps in the first programming assignment, make sure you contact me if you're having specific issues or post questions to the discussion board. All of that could be helpful. So, all right, so we'll look at the programming assignment number 3 near the end. I'll actually download that since I actually created it from home and do not have it on this computer locally, so we want to do that. We want to have that. Okay, so programming project number 3 is posted, and I will download this. Okay. Projects. There we go. Okay, we'll get to that in just a little bit. All right, so the first topic we're going to discuss, you'll notice that first of all, under session 8, you actually have the slides and the video lecture, and also the notes for session 8. But also you have again chapter 9 slides. I'm not going to repost those slides because they all go together for this week, but I did post some more notes related to this week. The first topic we're going to cover is called default member-wise assignment. So, default member-wise assignment, if you think of what a member is, a data member specifically, in a class, that means it's a piece of data that is used to describe the class. So it could be, for example, if we have a person class, it would have something like age, first name, last name, middle name, could have weight, height, employee number. Of course, that could be maybe an employee class. Social security number for a person, maybe in the United States. These are all things that describe the person, characteristics, attributes. If I take an object of the person class, let's say I have person A, I declare that object, and then person B, a second object. I set all of that data for person A, the age, the name, all of the different information about the person, and then I say B equals A. Well, what does that do? What does that mean? In some programming languages, you have to be awfully careful because that will cause the data to be pointed to by the same reference. But in C++, if you have just a stack-based piece of data, you have a stack-based object, it's going to copy data member by data member. So it'll copy the first name into the first name of B, it'll copy the middle name of A into the middle name of B, etc. It'll copy all the data over. So let's do the example that I have in the class notes. Okay. First things first, actually, before I even start, I'm going to just create a main file just because it feels more comfortable to do that. C++, and we'll call this main.cbp. iostream using namespace include name. Okay, so there's our skeleton main program that we're so familiar with right now. Now what we're going to do is I'm going to make a class that represents the full name of an individual. That's all the class is going to do. It's just going to be called FullName. So first of all, the header, create a new item. I'm going to make it a header file, and we're going to call it FullName.h. And I'm going to use the include guards that we talked about last week. H and if. Okay, so class FullName. Again, we put a semicolon at the end of a class. Make sure to do that. And you have the public and private sections. So what kind of data will we have in our FullName class? Well, we're going to have a first name, middle name, and last name. In order to do that, we're going to use strings to represent it, but to do that, we have to do this. We have to include the string library. Okay, so we've included the string library, and what we're going to do is we're going to make it so that what we're going to do is that we're going to make the three different strings that are part of our full name. We have string first name, middle name, last name. Okay, all these strings. And then we're going to write some methods here. We're going to write the prototypes for these methods. Set first. Oops. Out of the semicolon. Set middle. And we're also going to have set last. It's an L, not a 1, by the way. And then we have the get. Get first. Technically, you could make this const. In the example I show in the notes, I did not put const after these because it's not technically required, but it is good programming to do that, so we'll do it here. Last. Because these do not modify the data inside the class. So, okay, so we have a constructor and 6 functions, and then we have private data, first name, middle name, and last name. Alright, so that's basically all we need for our FullName.h file. Now we're going to create a FullName.cpp file, source file. Okay, so first things first, we're going to include FullName.h, and the very first thing we want to do is we're going to create our constructor. Okay, so first name we'll set to nothing, middle name set to empty string, and last name we'll set to empty string. Okay, so the next thing is set first. What this does is I take my internal data member named first name, and set it to F, which is the string that's being passed in as a parameter. The next thing I do is I'm going to call set middle, string M, and I set the middle name equal to M, and set last, string L, it's not a 1, again it's an L, last name equals L, and then I have all the get methods, get member functions. So full name, get first, return first name, string full name, get middle, return middle name, get last, return last name, Okay, so let's see what's going on here. Incompatible. See what the problem is. Turn first name. Oh, const. Yep, need const after. Alright, so that solves our problem there. Alright, so we've got all these methods defined now. Okay, and now what I want to show you is in main. So in main we're going to include FullName.h, right? And what I want to do is I'm going to declare actually two different full names. We'll call one of them full, and the other one we'll just call other. Very creative, I know. Full.set first, we're going to set it to John. And full.set middle, we'll set to Philip, that's my middle name. And then set last, Bob. Okay. And now what I want to do is, we know that I've set all this data for the object full, but when I say this, when I say other equals full, this copies with default member-wise assignment. So it's going to copy the first, the middle, and the last name in the private data from the full into the other. Okay, so all this data that I have, John, Philip, and Ba, it's going to copy into the object called other, even though we did not explicitly call set first, set middle, set last on other. All that data will be copied over. So let's see what happens here. I'm going to say cout. I'm just going to put the full name on this one. We'll say other dot get first, then a space, and then other dot get middle, space, and then other dot get last. And then inline. Let's see what happens. Okay. It build succeeds, and we're going to run it, and you'll see that it says John Philip Ba, not surprisingly. So that's what happens when you use the equal sign between objects. Now notice that this would not be the case if I had a pointer to a full object or a pointer to another object. If I used a pointer, that would mean that, and I set, let's say I had full name pointer full equals new full name, and full name pointer other equals new full name. This equals would then cause other to point to the exact same data as full, but it would not get its own copy. So that is a distinction that you must make. All right. So that's default member-wise assignment. The next topic I wish to discuss is composition. Composition is a software engineering technique that you'll probably hear a lot about, not just in C++, but in Java, C#, Objective-C, any language you take that involves object-oriented programming, you will hear something about composition at some time or another. You may not have recognized it at this point, but you actually have been using composition. When we actually use composition with this class right here, FullName. The reason this is composition is that it is composed of objects of a class that someone else defined for us. Since FullName contains first name, middle name, and last name, and these are each string types and not primitive data, since string is actually a class that some programmer made for us, this is technically using composition. We're going to be a little more explicit with it, but composition is known as a has-a relationship. Okay, this means that one class contains or has a member of another class inside of it. It is, in other words, a class is composed of another class's object or objects, and possibly even other class objects. So you might have 2 or 3 or 4 or 20 different classes that you have a single class composed of, and then that class in turn may be composed into another class. You never know. I mean, it's whatever you design. You also want to distinguish between composition and inheritance. A lot of people have trouble with this distinction. Inheritance, which we haven't really talked about thoroughly, I believe, according to the syllabus, that it's coming up in a couple weeks. I could be wrong, but let's just check that real quick, because I think it's coming up. I don't think we've covered it in depth yet, so let's look. Okay, yeah, inheritance is coming up in just a couple weeks. Okay, but to give you a sneak peek, inheritance basically means you take a general class and then you derive from that class and reuse some of the stuff that that class uses. For example, I might have an animal class, and then you would say that a mammal is a specialization of an animal. Also, an avian or bird is a specialization of an animal. An amphibian is a specialization of an animal. And then you might go further and say that a dog is a specialization of a mammal. A person is a specialization of a mammal. When you're inheriting behavior and attributes from classes that are above you in a hierarchy, we call that inheritance. And that's what we call an ISA relationship. An ISA, I-S-A, or I-S space A, I-S hyphen A, is a relationship, because we would say that a dog is a mammal and a mammal is an animal, correct? So that is inheritance. Composition is different. Composition is the car has a engine, or has an engine, right? We have an engine that's inside of the car. That's composition. An engine is not a car. A car is not an engine. A car contains an engine. Okay, it's composed of an engine. So that's different than the has a relationship. Okay. All right, so that's composition. We will make this a little more clear with an example. So I'm going to close these two classes just for now. I'm going to create another class that is composed of our FullName class here. So what we're going to do is I'm going to right-click the header file and header files folder, and we're going to create another header file, and in this case we're going to call it club member. So we'll assume that we have a fictional club that's made up of club members. Okay, if not defined, club member H, and define it. Club member H, these are the include guards we talked about last session. And then we'll class club member. Don't forget the semicolon. A public and private data section, just like before. Pretty much everything we do. This is going to be relatively simple, just to keep things easy for us. We will have. We do need the string class, because we're going to be using string as a parameter. Okay. For the private data, I'm going to have a full name, which I can't have unless I include that as well. I have to include the FullName class that we defined. Just like we do in main, I have to include this in order to have this class recognize it. So FullName, and also an integer representing the age. Fair enough? Okay, so the club member has a constructor, and we also have a set name, which will take a string first, string middle, and string last. That's why we needed the string library included. And a set age, which takes an int. Then we're going to have get methods, which will be called getName, and also getAge, which returns an int. Okay, so this is composition right here. I'm using another class, an object of another class. Right here is actually the composition. I'm using an object of another class, in this case FullName, inside of this other class that I'm making called club member. So club member contains or is composed of FullName, and then other data possibly from other classes. Could be, I could add a string down here, I could add another int, another float, doesn't matter. But in this case, we're just composed of the FullName here. Okay, so that's our .h file for the club member. For the source files, I'm going to add another source file, and this is going to be clubmember.cpp. In this case, I'm going to include clubmember.h, and then I'm going to do my defining. Now, this is what I like to do. I think I've showed you it before, but when I'm defining methods or member functions of a class, I like to just copy and paste them, and then I like deleting the curly braces and adding the scope resolution to them. Okay, so it just keeps me from having to type the whole thing over again. It's not lazy to use cut and paste as long as you know what you're doing, and as long as you don't like overuse it and are just completely lazy. So in order to get this to work, though, I have to have each of these with scope resolution to the club member class. Notice it goes before the name of the method, or the name of the member function. Right? Okay, so those are all resolved now. The first thing, with the constructor, what I want to do is I want to set all of the data members of our internal object FullName. I want to set all of these, which would be the first name, middle name, and last name, to some default name. Now, I could program it in the constructor, but the problem is I'm going to be redoing some of that in setName, because setName is basically what we need in the constructor. So I'm just going to call setName from the constructor after I've got this defined. I'm going to take FullName, which is our internal data member. I'm going to say FullName dot set first. I'm going to pass it first. FullName dot set middle. Pass it the middle name that's passed in as a parameter here, right? And then FullName dot set last. Pass it the last name. Okay. Then in the constructor, all I have to do is call setName, my own setName method. I'm going to pass it default first, comma, and then in quotes default middle, comma, default last. Default last. Okay, I could set the name to just empty, but it wouldn't really matter because that's the default anyway. I could put Billy Bob Hamstrings, it doesn't really matter. The next method we have is the setAge. Well, age does not consist of composition. We just have the internal data member age. Now, what do we do at this point? What options do we have? Because our internal data member is named age, and then we know that if we have a parameter and it has the same name as a global variable or as a data member, it overrides the data member. So I can't just say age equals age. That will do absolutely nothing. What that's going to do is it's going to take this temporary parameter here that's essentially a local variable to this method. When I call this method, it's going to set that data to that data, and then the memory that holds that is going to be destroyed. It's not going to put it in this age. Now, how do we distinguish between the global, or the data member age, and the parameter age? How do we distinguish between those two? Does anyone remember? Okay, think for a minute. Bueller. All right. You use the this pointer. Remember? This means we're referring to our own object. Whichever object has been created, this is the this. So if I say this age, I'm talking about my internal data member age. And then on the right side, this particular age right here corresponds to the one that's passed in as a parameter. So this works perfectly. Get name is relatively simple. I could just return FullName. Okay, and notice that will return an object of the type FullName. It may not be the best way to do it. We could break this up and cause it to return first, middle, last, whatever we want to do. But I chose to do it this way. And then return age. Okay, so we got return age, return FullName, and we've got all the set information here. So in main, I'm going to delete all this garbage here, and we're going to make use of our club member. So we've got club member. We're just going to call it member, and you'll notice it is not recognizing it. Let's just change this here, club member .h. Now it'll recognize it. You say member dot set name, and put Billy Bob Robertson. Put any name you want, really. Member dot set age. I'm going to set it to 20, and then I'm going to prove that this is working. The composition is working. Now, what happens when I call get name? When I call get name, it returns a piece of data to me of what type. What does getName return? It returns a full name. Well, full name is another class that I defined, right? Okay, well, if I want to do this, it returns that full name, and then I can just do this. I can say dot first name space, and then I'm going to say member dot get name dot middle name, and then member dot get name last name. Right? Okay. Let's see what is the problem here. Public operator or conversion pointer to function type. Well, live television, we will see what the problem is. Call of an object of a class type without appropriate operator. Or conversion functions to pointer to function type. First name is a string. Maybe it's because I'm not including string. That shouldn't be. Okay, it's saying that first name is inaccessible. Well, let's go back here and see what the problem is. Aha! Now I see what's going on. I'm an idiot. Okay, here. I'm not calling get first. I'm trying to apparently access private data members. That's not good. Okay, that's the problem. Has nothing to do with this. All right. See? This is why we do this. Live television. I watched you. I let you watch me go completely insane and forget what I was doing. Okay, perfect. That's why it didn't work. I hope everyone noticed why it didn't work, because you cannot access the private data members, and I was using functional syntax, so I'm actually kind of surprised it recognized what I was doing, kind of. So, but regardless, there were no methods that were publicly available that I could access in that manner. So, all right, this is set now. Another thing you could do is you could create a full name object and then just set that to this, to member.getName, and then call whatever on the full name. You could call get first, get middle, and get last. Okay, so you could do that. I'll actually show you to do that. Full name FN. It does recognize it, and you might wonder why. Well, why does it recognize it? Well, clubmember.h actually contains fullname.h, so we have the definition for it. Could I put it separately? Yes. That's actually what the include guards are for. That would prevent us from including it more than once, so that's good. But I'm going to show you what we can do here. I'll say fn equals member.getName, and that should let us use it. Okay, and then I could also do this. I could say fn.getFirst and fn.getMiddle and space, and then fn.getLast. And now I'm also going to put some space in between these two, so we can see that it works for both of them. Okay. It works either way you do it. Okay, succeeded. We're going to start without debugging, and you'll notice it has the name twice, which is exactly what we expect. Okay, so it works both ways. Alrighty, so the next thing I would like to cover is the friends topic. So I'm going to take a quick break, which you won't notice because I'm going to pause the recording, but I will be back in just a second and we will pick it up with friends. Okay, back to work here. We've got friends that we're going to be covering. You might think you're a social butterfly, but you're not the only one that has friends. Classes can have friends also. There are two types of friends that we will talk about. There are friend functions and friend classes. A friend function of a class is a function defined outside of that class's scope but has the right to access private and protected, which we haven't covered yet, members of that class. A friend class is a class that is given this access to another class's private and protected members. So the class, a friend class has full access. A friend function is just a single function. Some programmers feel that using friends is bad software engineering because it violates encapsulation. I do tend to agree with this for most circumstances, but there are reasons to use it, especially in special circumstances such as with operator overloading, which we'll cover in the next chapter. So let's add a friend to our club member class here. Right here, I'm going to, you'll notice here, above the public and private sections of this class, I'm going to add our friend, because a friend is not actually a member of the class. Okay, a friend doesn't really belong in the private or the public portion of the class because it's not private or public. It's a friend. So we've got friend keyword, void, friendly age setter, club member, and then don't forget the address of operator, so we can actually modify an instance of this class and an integer to set it to. So basically what this is going to do is it's going to be a function outside of our club member class, and it will let us change the data inside of the class. So let's go back to main. I'm going to change or delete all this stuff right now, and I'm going to create our function at the bottom here, void friendly age setter and club member %C and int a. And you'll notice that I can actually say this. I can actually say c dot age equals a, and it doesn't flag it as an error, even though age is a private data member of this class club member. I'm allowed to access it because I declared this function as friend. Okay, this is not a member function. Okay, because it's not actually a member of the class. But because I gave this function special access, it can access the private data members. So let's see this in action. So I have club member, so member.setName, Cy Bob Robertson, okay, member.setAge to, we'll say 70, okay, and we'll say member.getName.getFirst, alright, and then member.getName.getMiddle, okay, and I'm actually going to go to the next line here, member.getName.getLast, and inline here. And something I did actually neglect to do last time, I'm going to say get age right at the bottom. Okay. And then I'm going to do a couple inlines here. And I'm going to call my friendly age setter. I'm going to pass it member. So it passes this by reference. It passes a club member by reference. I'm going to set the age to 60. Okay, so it'll go from 70 to 60, and let's see if that works. Okay, and then I'm basically going to copy and paste all this stuff here. This is going to re-print out the information for me. Okay, so let's see if this actually does what we expect it to. Okay, no errors, that's good. Start with the debugging, and you'll notice that it's Cy Bob Robertson. I actually forgot to put a space in between the middle and last, but you get the point. Cy Bob Robertson 70, and then Cy Bob Robertson 60. So it did actually change the internal data of the class, even though this is not a data member, because we made it a friend. Okay, use sparingly. Don't use friends all the time just to fix up stuff. Most of the stuff you can get away with would be you could do with just member functions. There are some circumstances where you'd want to use it. Some of them are outside the scope of this class, but some of them we might get to next week. So, all right, so that's friends. I didn't give an example of a full class. I believe they have maybe a full class in the book that does the friend, but if anyone wants an example or you want something specific or can't find any information on it or are interested, you can contact me and I'll post a more thorough example. But I think that at least shows the basics of friends. So the next thing we're going to cover are static data members. So if a data member is declared static, then it is shared amongst objects of the same class. Okay, so you can access it through the class's name, not a specific object. This is useful in circumstances when you have a class used for utility and not to create specific objects, and also like the math function or the math library. The math library is actually a good example. Another reason might be to track how many objects of a class you've created. So we're going to create a static member data member to track how many objects of the class have been instantiated. We'll also create a static member function that returns this data member's value. So I'm just adding a couple things to my clubmember.h. Right here I'm going to say static int get count. Now what that means by declaring this member static is I can access the static data, and I don't actually need an instance of this class to access this member function. Okay, static int count, and you might wonder, well, how do we initialize the data? Well, it's a little bit different than you might be used to, but it's not really that difficult. The way to do it is we mosey on over to the clubmember.cpp, and then near the top I'm going to say int club member count is equal to 0. Okay, so that basically sets the count to 0. That's how you initialize it. It's only done once when the class comes into scope, not when an object's created, but when the class is just included, essentially, is what happens. The other thing I want to do after set name is I want to do count plus plus, because I want it to count every time I create a new member of this class. The last thing I want to do is create a get count function. Now you don't put the static keyword here in this file, you don't need to. Notice I didn't do it up here either. So I'm just going to return count, and we're good for that. We're good to go. So that and this, and notice the static keyword is only in the .h file, the name of the function, and also the name of the data member. Okay, so main, first thing I'm going to do is I'm going to delete all this junk out of here. I'm going to first print out, I'm going to say number of members, and we're going to have club member, and notice now I'm not using the dot operator. Some programming languages use the dot operator, like Java, but here I'm just using the scope resolution operator. Okay, get count, because if you're ever using it and it's static member, you use the scope resolution operator to access it too, in addition to when you define it. Okay, so it might be a little bit squirrely. You might wonder, well, what the heck, we didn't even create an object of this type. Well, that's true, because we're accessing static data and static method here. Okay, so that's perfectly acceptable as far as C++ is concerned. You could create a class and you don't have to have any actual objects of that class. Club member, and then club member 1, member 2. Let's say club member 3, and then I'm going to print out the number again. Oops, that should be member. Club member 3. Okay, I'm going to print it out, and then I'm going to do this again. I'm going to say club member 4, club member 5. I'm going to print it out again. Okay, so let's see what happens. See if this works the way we expect it to. So build succeeded, I run it, and the first time it's printed out is before we have any members created. So that prints out as 0, which is what we expect, because we've not created any members. As soon as you create the first member here, club member, Every time you create a member, it calls the constructor. Remember, when you create an object, it creates, or it calls the constructor. So it set the internal names, and it also incremented the count, which is a static piece of data. Static piece of data. All right. So we've got that. We do that 3 times. So how many do we have at the end of that? Well, you have 3. Okay, 1, 2, 3. That's what we expect. Then I create 2 more, print out the number of members, and I have 5. That's exactly what we expect. So that's static data members. Okay. The last major topic of this chapter that I wish to cover is exception handling. I'm just going to do a brief on exception handling. If you're more interested, I would recommend reading in the book a little bit. For this example, I'm just going to close the 2 classes. We don't really need the classes right now. I'm going to remove that. I'm going to also get rid of that. And all of this. Okay, so we're basically got a skeleton here. I'm just going to show you how this works here. So an exception, which we've alluded to before, an exception is something that occurs that can cause the program to crash. In other words, we are talking about a runtime error. We have a different way of handling exceptions, or different ways of handling exceptions, but I'll demonstrate one here. There are some built-in exceptions. For example, you can access some of them from see, exceptions, one of them, bad exception, exception pointer. There's all kinds of different exceptions that you can access. But the one that we'll deal with, we'll just deal with the general exception, and we're going to make it kind of specific, or at least the data in it specific. I'll show you what that means in a second. Strangely, C++ doesn't have a built-in exception for divide by 0 like a lot of languages do. I'm not sure if they've added it in the standard. I'll have to look into that. Okay, so but this is a try-catch block. So in the try portion of a try-catch block, you put what is considered the dangerous code, and then the catch portion you put what do you do if something in this dangerous section goes awry. In other words, if an exception is thrown. Okay, we call that throwing an exception. So this is going to be a division problem here. We're going to have result equals 0, or result equals A divided by B. And we don't know. I mean, we could be taking the data in from the user, but this is to just force an exception to occur so we know what's going on. If I run it now, it's going to crash. Okay, it should crash. Let's run that. You'll notice that I do actually get a session 9 has stopped working, debugger close the program. And just to show you quickly what happens in the debugger, if I start debugging, should work here. You'll notice that it will immediately point and say that there's an unhandled exception. You'll see a little arrow here. It'll point to where the exception is. It's a integer division by 0. Okay, that's pretty helpful, right? So we know, if I stop debugging here, and go back to the editing mode here, and then we'll handle that exception. It's called that's called handling the exception, is determining what you do if the exception occurs. Okay, so before I actually divide by 0, I'm going to test that denominator. I say if b is equal to 0, I want to throw an exception. In this particular exception, I'm going to just say divide by 0 exception. Divide by 0 exception. Okay. Now, what does this do? Well, an exception is a class, actually. An exception is a type of class. So when you throw an exception, basically that's creating an object of this class, an exception. And then when you pass this to the essentially we can think of it as the constructor. It's basically just a string that goes into this class object's data, and then we can retrieve it with something called the what method, W-H-A-T, what. So if I want to know, let's say result, I'm just going to print the result there if it's successful. If not, I want it to say e.what. Okay, it's a method. So let's see what happens. Let's first of all let it work correctly. I'm going to say b equals 2, and the exception will not be thrown because the denominator is not 0. It'll just run and it'll say 5. right? Because that's what the result is. Integer result of division is 10 divided by 2, that's 5. If I set the b equal to 0, and I build and I start without debugging, it's going to not crash, but what we call fail gracefully, because we handled the exception. You notice the operating system didn't have to handle the exception. We didn't get a big pop-up that said, oh, it stopped working, your program stopped working. It just says divide by 0 exception. This may not be a nice thing to happen while you're in a program, but it's a lot better than the program just crashing or having the operating system handle the exception. We definitely don't want that to happen. So there's also a finally block. I didn't include this in the code. So this finally is undefined. Sorry about that. In some languages, they support a finally block, like Java or C#. C++, you can actually simulate it, but it's like pulling teeth. The reason this is turning blue is because it does have actual meaning. But you have a finally block in some languages which cause whatever's down here to occur regardless of whether there's an exception or not. But we don't really have that in C++. I had a little bit of a brain issue right then and forgot something. I'd been dealing with C# earlier today, and I'd forgot that C++ didn't actually have that. You'd think they would have added it to the new standard, because it is very helpful. But, all right, so you've got try and catch blocks, and anything that's dangerous you put in the try block. You can throw an exception. Some exceptions get thrown automatically by the system, like if you go to an array out of bounds, that is actually an automatic exception. One way to catch generic exceptions is to just write catch, and then in the parentheses you write ... That's if all else fails. There are different types of exceptions, so if none of those work, you can actually say catch ... It's kind of like doing a generic exception. This is pretty close here. Okay, so that's exception handling, and that's all I have as far as the course material for the day are concerned, but I also have a programming assignment that I need to go over with you guys. Okay, so we've got the programming project posted, and it's programming project number 3. All right, and the purpose is to understand, it's worth 125 points. The purpose is to understand software using arrays and previously learned programming constructs. You can use, I'm going to let you use the array or the vector data types, or you can use built-in arrays, which we've talked about. The instructions are, for this assignment, you will create a memory game similar to the card game that many of us probably played as kids. For the memory game, you'll allow the user to select an index of an array. Remember, arrays are indexed by 0, right? Index of an array of characters, so that you're going to use the character data type, and you're going to try to find the matching character. If you guess wrong, you quote-unquote flip the card back over, and don't reveal it any further. If they get a matching pair, then you display both of the characters, and you should keep track of how many guesses or rounds the user requires to unveil all the matches. Thus, the array has 10 elements, yielding 5 pairs. A, B, C, D, and E, just to keep things simple, is probably the best choice. Behind the scenes, you will have an array that looks like this. Okay, this is, just a simple example. You don't have to make your array in this order. You also don't have to randomize them unless you just want to. That's probably more complicated than you're thinking, so probably I would recommend, if you're very adventurous, just use a standard array and set it to specific items. You could use vectors or what have you, but just make it not an array that shuffles or changes or uses a randomizer. I would just use the basic array here, or anything of the sort. However, the user will actually only see this. You'll use like hyphens. Okay. At the very beginning, you do this, and then prompt the user to enter a number. They enter, for example, a 0, and that's the index, so that reveals the card, quote-unquote, at 0, which is A. Then they reveal a 1, So it puts AB, it says sorry, no match, and then it quote-unquote flips them back over. Now, this will all be going down the screen of your console. Okay, it's a console application. So it's kind of a bad game in this case because you can actually see what happened previously. There is a way, and there are ways to clear the screen in C++. If any of you are extremely interested, I can post a short tutorial on that if you wish, but you don't have to. It's not required. This is just to see if you know how to manipulate arrays properly. Later on they might pick 3. 0, 1, 2, 3 is the position that gets revealed, and then they pick 0. Matches both of them, so it should say you've made a match, please continue. And then this will keep on going until they reveal the entire set. Okay, so the user continues playing after the letter's uncovered, and then at the end you should say, congratulations, you've matched all the cards in some number of tries. The sum number of tries should be the number you've tracked, how many tries they've made. A try could be considered, if you want to count a try as every time they reveal 2 cards, that's fine too. But I think the way I did it here is just every time they flip a card over. I think it's 1. Okay. Recommendation, I think it would be good to use parallel arrays. That means you have 2 arrays, and basically the indices at each of these 2 arrays indicates that they're representing one item. For example, let's say I didn't know about classes, or I didn't want to use a class, and I had one array of names and another array of integers representing weights. So if I looked at index 0 in each of the arrays, index 0 in the string array, or the name array, says John, and then index 0 says 190, or something like that. Okay, so that's a weight. So we would say John's weight is 190. That's a parallel array. When you use 2 or more arrays, and each of their indices represents an individual entity. Okay, but different data about an individual entity. One contains the actual letters. One of the parallel arrays contains the actual letters, so that's what you're checking against behind the scenes. One is used to display the appropriate cards that have been revealed. For example, the stuff that's shown to the user. You might need 3 arrays. You might need 4. It's whatever you choose to use. If you get much more than 3 arrays, you might be doing something wrong. 3 arrays would, I could see a way to do something handy. Again, these are recommendations and hints. But you should design a class, okay? This is actually required. You should design a class called CMemoryGame that maintains the state of the game, interacts with the user, and determines the winning state. Failure to use a class will result in significant loss of points. Let me say it again. Failure to use a class will result in significant loss of points. If you don't use a class, you will lose points, okay? Plain and simple. You have to also write a driver main.cpp file, for example, that instantiates an object of type CMemoryGame that will allow me to test your programs. I should also be able to copy and paste or move your files and use my main function without yours. I should be able to do that. You should not tie everything in so dramatically with main that I can't, repeat the functionality. I can't call member functions of CMemoryGame or something like that. Don't do that. Deliverables, you're going to turn in your entire project zipped up. Actually, the solution, technically. You attach the zip file, submit it to the appropriate assignment folder. Do not cut and paste the code. Send anything to me in email, carrier pigeon, anything like that. I will not grade it if it's not on Desire to Learn. Okay, so no paper copies or anything like that in my mailbox randomly. Of course, seeing that this is an online course, I think that it should be natural that you have the stuff turned in online. So, all right. If you have any questions, please email me or discuss it at the discussion board. Please keep up with your own grades. Regardless of who you are all responsible to keep up with your own grades. It's in the section over here under grades. You should be able to, see your actual grade if you log in. You'll see something different than I do. So that will actually show the grades. Sometimes, depending on the assignment, the stuff's under here. You should be able to see. All right. So again, if you have any questions, discussion board Let's see if there's anything else on the discussion board. Nope, no new messages. I think everyone's on vacation early today. So, I will see you guys sometime next week, talking to you. Well, won't actually see you, but you will hear me at least. If you have any problems, or let's say you got a bad grade, this is another thing I wanted to discuss. If you got a bad grade, or a grade that you were not really happy with, I'm not talking like 2 points off or something like that, but if you got like, a C or less specifically on your programming project 1, I would highly recommend contacting me. I would highly recommend emailing me. I will still let you make up some of it. I'm not going to be a complete ogre about some of the makeup stuff. I would say if you're, wondering what should I focus on, well, focus on the projects that are going on now. But if you're having an insane amount of trouble with the projects, you need to contact me, and we either need to meet up at my office, or we can talk over email. We'll work out something, but I want to make sure that you're all successful in working with this. So just don't be embarrassed to contact me. I mean, I see your grades. I see what stuff you've done, so if you've completely jacked up your assignments, I know if you've jacked up your assignments, because I remember I'm the one that made the comments. There's nothing embarrassing in admitting you don't understand something. There is something embarrassing about hiding and then getting a bad grade that you're not hiding from me. So just, if you need any help, just contact me. We'll work something out. All right. Thank you, and you guys have a good week and have a good 4th of July. At least that's when I'm recording it. You might be seeing this lecture afterwards, but I hope you all have a good 4th and everything's good for you and your families. Thanks. Bye.